In all three examples that we have used so far, which was, of course, register operand, immediate operand, direct memory operand. What's common about these types of operands in our instructions is that every time if we try to run this code in some kind of loop and repeat these instructions, every time we run through this instruction, it's exactly the same operand, it's exactly the same register, or it's exactly the same immediate value, or if it's it's exactly the same place in memory. So that's what kind of common about them. So there's nothing indirect. Everything is direct in all three examples. The rest of the examples that we're going to use here is going to be using some kind of indirection. What is this indirection in our examples here? What could we do? For instance, register indirect addressing can be done like this. We have seen this already. So sometimes we want an instruction to do something different. For instance, we can move into register EBX an offset of this label in our data segment. Right? So basically we're just going to load the address, and then we can do this, we can try to repeat this by saying add EAX, and now using EBX. So because we're now using a register which potentially could change, we could have more code over here written. So by the time we get to this instruction, maybe we're loading different variable addresses into EBX. So by the time we get here, we know that EBX specifies the operand of the same size of this 32-bit register, but what we're doing here is we're using a register indirect memory operand. So this is a register indirect memory access. So indirection is based on the address that is specified by the register, and again the square brackets clearly indicate here in this instruction that what we're doing here, we're just going and accessing some sort of object in memory whose address is already loaded into register EBX. So this is the first example of indirect memory addressing, and it's based on the value on the address inside this specific register. And we can of course use all general purpose registers to access values in memory. One quick note that I'd like to make here is that here, if I take this value and try replacing register with this, okay, so this would not be possible because we're just simply getting invalid instruction operands. Because remember, one rule is that only one of the operands with two operand instructions, only one of them can be in memory. Okay, so it's not possible that this add instruction would be able to access two different places in memory like this would suggest. So this is not possible. Okay, so only one operand can be in memory, and that's usually visible through the application of the square brackets that we use in Microsoft macro assembler syntax. So since the value in this register can change at runtime, this idea of indirect memory access provides clearly dynamic access to memory. Dynamic means that, once again, we can loop through this instruction multiple times, and depending what happens above it, how we load this register, it could be accessing different places in memory every time we execute this same instruction, because the value in EBX could change.